Can we really deliver more for less on capital and construction projects without increasing risk or compromising scope and quality? Well, we believe that we can, but we need to make a number of changes, and this video is about one of the core changes at the heart of breakthrough project management. It's how we plan and how we control and manage execution, and we'll be talking about using a method known as CCPM, Critical Chain Project Management. Critical chain was introduced to the world at large in 1997 in this book by Ellie Goldratt. What critical chain does is it codifies quite a lot of what the best project managers have known intuitively anyway. But in addition to that, it takes a systemic focus. It focuses on the project as an end-to-end system and works out and has analysed and discovered ways to overcome the issues which prevent a project from flowing smoothly, quickly and in efficiency. Now there's many differences with the critical path methodology, some at the tactical level and some fundamental. I'm going on this short video just to talk about the three core rules of critical chain project management and demonstrate how those differ from many of the common approaches, particularly those used in the critical path methodology. Now, CCPM is much more than just an alternative way to plan. This is not like a methodology that it doesn't really matter which one you use because they all deliver similar sorts of results. If you look at the kind of results that CCPM has delivered, we're talking about projects delivered 25%, 40% faster than before. So the results of the project are available to the client significantly earlier than would otherwise be the case, but without just throwing resources at it and working inefficiently. Critical chain has allowed organisations to have 25–50% increase in project throughput. What that means is the same resource pool, the same number of people, the same costs are delivering many more projects, which in turn reduces the cost for each individual project. Now you might think that all these improvements must come at a cost of due date and completion performance, but no, critical chain project management also projects hit their target dates much more often. 90–95% are not at all uncommon for companies implementing critical chain project management. And it's not only beginners at project management who've benefited from these sort of improvements. Take a look at some of the companies that have gone into the public domain and talked about their experience using critical chain. Boeing in designing, developing and building aeroplanes. Tata in the steel industry, managing plant shutdowns in much shorter duration. Seagate developing new electronic technologies. Mazda for new motor cars. Totally new models. The recent MX-5 was fully managed using critical chain, developing new technologies all the way through to market launch. BHP Billiton in constructing new factories. And down at the bottom, the Japanese Ministry of Land Infrastructure, Transport and Tourism, the largest spending ministry in the whole of the Japanese public sector, has been using critical chain and encouraging its use across their construction supply base for well over a decade now, delivering the same sort of benefits and improvements. So this isn't just let's plan in a different way. Now, what makes it different? I'm going to focus on the three rules that I've got on the left hand side of this diagram. We're going to see multitasking as a sin. We're not going to manage projects on the basis of task deadlines in individual work packages, and we're not going to manage priorities based on the most senior project manager or the person who shouts loudest or annoys us. We'll go through those in a little bit more detail over the next few slides. So the three rules tackle major source of waste and inefficiency on projects, and the first one is task switching, also known as bad multitasking. For tasks that a particular person on a project is expected to work on at the same time. Now, the conventional approach in much of today's project world is that those are worked on in parallel. Each of the people responsible for blue, orange, green and red expects to see some type of progress on their work and activity. But of course people can't work in parallel, so what that means in practice is that blue will start a little bit, then we'll switch to orange, then we'll do some green, then we'll do some red, then we'll get back to blue, and the owners, the responsible managers for these tasks, can see at least some things happening on their project as they go along. Now that has a number of disadvantages. One of the key ones, of course, is that the progress of tasks in little parts is not as neat as that. It stretches out. There's inefficiency and delay as you put one task down and pick another one up. Particularly if we look to here where blue is picked up again after working on red. So the person working on task, now where was I up to? What was I doing last time? So there's a little bit of rewinding to go over what you've done before, and then you've got to get whatever you were doing for red task out of your head until you're fully up to speed again, and that is extremely inefficient. It's much worse than is indicated schematically in this diagram, where that chain is about 15-20% longer than it would otherwise be. Where in some of our workshops where we run some simple group activities for multitasking, in general the multitasking environment where you switch between tasks before it is a convenient and efficient time to do so adds at least 100%. It doubles the amount of time the whole sequence of tasks takes, maybe even triples it very often. So we get inefficiency just by jumping from one thing to the other. The human brains are not designed to keep jumping that quickly from one thing to the other. The other issue that we had is if these 4 tasks were worked on with focused work and effort. So rather than in parallel, we did one after the other, and this is exactly the same amount of work content. In the multitasking environment, blue is finished here, orange, green and red. So all this time the person is working, they're not producing any deliverables. Then all of a sudden, deliverables come out in rapid succession. Now that lack of smoothness in passing work to the next stage of a project creates all sorts of waves and uncertainties. In the supply chain environment, this is known as the bullwhip effect, and it has a dramatic effect on the efficiency of any supply chain, and projects are no different. If we can get people to work in a focused manner without jumping from one thing to the other, the flow of deliverables is much smoother. Now that allows downstream tasks and activities to become much more efficient because they don't have to cope with peaks and troughs in workload. The other issue can be seen quite dramatically is, of course, blue is finished in 1/3 of the time that it would otherwise take. Orange is finished in half the time. Green is finished much quicker, and even red is finished sooner. So all the managers responsible or waiting for the outputs from this work or these projects get their results sooner. But culturally they have to change, because having somebody multitasking, if you're the senior manager waiting for the output, it's very reassuring to see that people have started work in this multitasking environment at the top right. At least we can show some progress to the person who's overseeing and waiting for me to finish this work. I might finish late, but they're a lot happier earlier on. Now, if we shift to reducing the amount of work of multitasking and task switching, which critical chain strongly polices and encourages, the manager of the red task is going to get extremely nervous, because all this time is passing and they can't see any progress, any starting. Now, of course, that's a good thing, because they will get their completion sooner than if the work resource was multitasking. But today's culture is the only way you get your deliverables on time is if you make sure that people have started and you pester them and shout at them. So that's just a little example of how moving to critical chain, whilst it makes perfect logical sense, the practices that everybody has learnt in order to meet their obligations and to do a good job is actually opposite of what critical chain will require. This requires the managers of the orange and the green and the red to say, I'm happy that you don't start, you keep working on blue and then orange because I know I will get red faster. So multitasking is rule number one. The second major source of waste that CCPM tackles is working to fix task deadlines. Critical chain does not require individual tasks, individual work packages to commit to a firm completion date for that task. Critical chain focuses on the project. Doesn't matter if individual tasks are on time, early or late. What's important is that the project is on time. So let's have a look at how that's done. So let's take an individual task like this one and assume that that duration is, say, 5 months. Now, what that means in reality for the way most projects are run today is I'm 90% certain it'll take 5 months. In 90% of the circumstances, 5 months is enough. This is a highly probable completion date, but we know that life is very uncertain. So what's remaining unsaid is that there's actually a 75% chance I'll finish in 4 months. Maybe a 50% chance, if I'm lucky, I'll finish in 3 months. I might even have a tiny percent chance I'll finish in 2 months. Now, we all understand this intuitively. If any of you work in major cities and commute to home outside the city, you know that your average journey time might take 50 minutes. If you are travelling on a Sunday morning with no traffic, it might only take you 25 or 30 minutes. But I bet the longest it's taken you has been several hours. Now, if you've got an important appointment at home, you'll probably leave several hours' time. And the same happens on the traditionally managed project, where people are expected to give dates for completion of their task, and if it's subcontracted work, a fixed price quotation that covers all eventualities, and that pushes people to give this highly probable time. Now, critical chain takes a different approach to working with the uncertainty on individual tasks within projects. When this task shows a duration, what that is in most projects is a period of time that I've got a 90% plus. I'm highly certain I'll be able to finish it. That breaks down into a certain period of time that I'll hit in half the circumstances, 50% of the time, and what we're going to call some safety time, because I believe I need to give a highly reliable due date. It's not padding. I will need it in many, many different circumstances. So if we take the same overall very simple project, and now I've split each of the tasks into the 50% time, so this is an aggressive duration. It's possible, but not probable. And then some safety, which will take me up to a highly likely, highly probable completion date of my individual task. So what critical chain does is it takes all that safety and puts it to one side. The logical sequence of tasks doesn't change, of course, but it puts a program together based on these 50-50 times. Now, it's very unlikely that every single task in a project will hit or better its 50% probability. So the project will still need some safety time, but critical chain puts that safety time at the end of the project as something that all the project activities share. It's known as the project buffer. Now, statistics and experience has shown that we need a lot less safety than we built into the individual tasks if it's aggregated and shared across the project. Now, that makes sense to us intuitively, because at the start of the project we know that some tasks will take longer than this 50-50 time. We just don't know which ones, but it's very unlikely they will all need it. And now we've got a shared pot protecting the end date of the project, we need less in there. So that's the idea of the critical chain project management schedule. As well as this project buffer, we also have some strategically placed buffers within the overall schedule. In this case, you can see that this is the longest sequence of tasks and activities dictating the project duration, But we've got some feeding chains coming in at various integration points, and those durations are only 50% reliable, so we need some protection to make sure that these feeding chains don't delay the progress of the important part of the project. So the critical chain is like the critical path, but you always take account of the resource availability, which is very often ignored when using the critical path methodology. For this simple demonstration, I'm not going to go into that level of detail. So critical chain schedule is typically about 25% shorter than your average plan. The third rule within critical chain project management is about managing the execution, using the buffers to give you a much earlier indication than is normally the case of how well the project is going. And it's also a methodology that allows much faster feedback of progress, almost real-time information to the project manager. So you know what's happening almost on a day-to-day basis, so you can decide where to leave well alone and where might need some help and support to get the project back online. I'm going to indicate the use of that and how critical chain uses a very simple and intuitive traffic light colouring system to direct everybody's attention, project manager and resource managers, to where the most important areas of the project are. So if we look at our simple project again, we start some work on that first task down here that's just turned brown. Now, as the project starts, this task manager has made a little bit of progress, but thinks that this task will be finished about then, much later than the 50-50 time. So the impact of that is it will push all the subsequent tasks forwards, and the end date here has used some of the buffer up. That part of the buffer has been used by this particular task. So we've made about 10% progress along the critical chain, but we've used 30% of the buffer up. Now intuitively, if I keep going at this rate, by the time I've made 33% progress on the project, I'll have used all my buffer up. Maybe I need just to make sure that this is a one-off, that there isn't something systemic going wrong with this project. So I've got a bit of an early warning. Now, the way that this is used in most critical chain implementation is using a simple graphical method where the project plots how far the project is complete along the horizontal, and on the vertical we look at the percentage of the buffer that's been used so far. So a perfectly average project would move from 0 up to project completion and using all the buffer up. Remember, the buffer is not padding, it's safety protection that will need to be used. And the project we've just looked at is positioned here. 10% progress made, 30% of the buffer used. We can see it's a long way away from the average yellow line. Not looking too good. Now, the way that most critical chain implementations and software packages demonstrate that is shown on this image here with what's known as a fever chart, where areas of this graph are coloured green, yellow and red intuitively. Red is bad, green is good, which approximately follow the straight line, but with a bit of give and take, so that right at the beginning you don't overly worry about minor deviations because the project is only just getting underway. However, this particular point that we've just seen is clearly in the red here. Red means implement recovery actions. The project team is expected now to be doing something to recover some of that buffer. Green means just keep going. Yellow is often a signal that watch the trend closely, maybe prepare some recovery actions if the project gets into the red. And then as the project progresses, you get a sequence like this, where it's in the red, the project team did something, maybe it was some overtime, maybe it was some support to limited resource, recovered some buffer, and did the same here. And now the project is about 80% complete. 75% of the buffer has been used, so not too bad at all. However, recently very little progress has been made, but an awful lot of buffer has been used. So we need to watch very carefully this trend, make sure that they've been at least planning some contingency actions, so that should this trend continue, they know exactly what they're going to do to make sure they hit the due date without using more than 100% of the buffer. So what we've just talked about there is the use of this fever chart on a single project within a single project team. Clear priorities for everyone working on the project, red, yellow, green. The same idea can be used at the next level of management up in what's known as the portfolio fever chart. On this one we show 8 different projects at any moment in time, so this is the latest progress report. And it can be seen at a glance. Projects B and C are doing quite well, and as a senior manager, leave them well alone. Just plan their celebration party. Projects D, F and H, however, are all in the red. So as a senior manager, I know which projects to focus on, which to see what support they need to make sure they're implementing recovery plans. A, E and G are progressing as they expected. So in a single diagram, I can see how a project is performing on the left and how a whole portfolio, potentially of hundreds of separate projects, without going through each in detail, single glance, I know which ones warrant my attention. So there are 3 rules. No more task deadlines, put the uncertainty into shared buffers, and then use buffer management to manage the progress. No more he who shouts loudest. And then limit the work in progress. Stop multitasking at an individual level, and if you're managing a portfolio of projects, make sure that you stagger their release and the organisation isn't working on too many projects at once, because if you do, everything just slows down and becomes inefficient. So those are the key elements of critical chain project management, and it works. The same project using exactly the same project team gets delivered on time in less time, on budget at lower cost. Remember the sorts of professional global organisations who've proven this within a few months of applying the methodology. But there is a catch, and particularly one where we're working in capital construction projects. Now, one of the features of capital and construction projects is almost all the work is done by a third party and there's a contract in the way. And the most common approaches used to selecting and contracting with that external project team just don't include collaboration. It's all about win-lose, who is at fault, who's to blame. We want fixed prices, we want liquidated damages. We try and offload and push risk and uncertainty down the project supply chain and the work breakdown structure, which is totally the wrong thing to do. Pushing risk to the lower levels, as we've just seen in critical chain, increases the risk that the whole project takes much longer than it needs to be. And also it will cost much more and be a lot less efficient. So clients thinking they're doing a good thing by pushing risk down the supply chain are often not aware of the enormous strategic impact that's having. It's costing them more and it's taking them longer. That's what critical chain can help you overcome. But it requires a collaborative project team. You've got this shared buffer. You don't know at the beginning who's going to need more time and effort. You've got a mindset that says we work as fast as we can and we pass to the next person in the chain as soon as we've finished. There are no fixed handover dates. And the whole focus is on making the project successful, not just our little bit. And in order to do that, in order to exploit the power of critical chain project management that we've just mentioned, shrinking your project by 25, 30, 40%, delivering more projects with much less resource. You can't do that unless you've got a collaborative project team, which means you have to select the key members of your project team using a collaborative contracting and selection method. And within breakthrough project management, we favour an approach known as project alliancing. And in the next video in this series, we'll tell you something about the project alliance. I hope to see you there. Thank you for listening.